Hey guys, what's up? It's Claire. I'm back. And we have Chapter 5 of Aroids, Plants of the Aurum family by Denny Bown. If, for some reason, this is your first video of mine you're watching, I have been doing this little series since last year where I kind of take you through a fairly famous but out of print and therefore extraordinarily expensive plant book called Aroids by Denny Bown. Enough talking, Claire. Let's get into learning. Chapter 5. Sorry, Chapter 4, last chapter, if you watched that, if you didn't, go watch it, was about wetland aroids, so the super wet boys. Today, we're about the super dry boys. It's called A Place in the Sun. Species of arid and seasonally dry regions. I heard that and I thought, oh, this is just going to be entirely about Australian aroids. I was wrong. While Australia is mentioned, there are a lot of places in the world that are also dry and aren't Australia, and we will look at them. But I guess that just reveals my ignorance when it comes to geography. Like, in my mind, there's Australia, which is dry, and then there's the equator, which is rainforest, and then it's just the North Pole. I do know a little bit more than that, I think. The little hook that Denny uses to get us in to capture our attention for the start of this chapter is as follows. Sun-baked hillsides, exposed cliffs, dry grasslands, and scorching deserts, which is why I thought Australia, right? Are surprising habitats for aroids, which yes, they are. If you can see this is a humidifier I have next to me for my humidity-loving plants. Yes, they are spoiled. That's all I can say about it. I love them. The thing about this chapter, before we get into it, it builds us up to be like, yeah, these plants grow in really harsh conditions and full sun and not a lot of moisture and blah, 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 blah. But these are plants that are dormant for a fair amount of time. Like during the dry season, they're dormant. They've adapted in the way that they avoid the hot and dry conditions. So they come out during the wet season. They have a short leaf flowering period. It's kind of cheating if you ask me, but I'm not the plant police, so I guess they can do what they want. They're the same as any other aroid in that they need to keep water loss to a minimum. They need to maintain a certain level of hydration. I suppose they're not like a cactus which can survive for months on end without water. So for that reason, they need to grow in shady and moist areas or niches. And for a lot of them, they go underground to escape the heat and drought of summer. So again, kind of cheating. They've got starchy tubers. So you're not going to find many of your, I guess, traditional houseplants in the sense of Monstera. Not too many Anthurium or Philodendron. They're kind of the minority. The primary tribes are Ariae and Spathocarpae, which we will get into in a moment. Some of them do have fairly lush foliage, but they're toxic, so don't eat them. And it's to kind of, I guess, scare away the animals. Typical habitats of these plants are thickets, scrubs, grassy waste ground, rocky, stony places, meaning kind of the Mediterranean and Middle East, or regions with a Mediterranean climate. So this is characterized by hot, dry summers, relatively warm winters, when most of the annual rainfall occurs, so in winter. So you can find aroids under trees and bushes, bases of rocks and walls, near springs, near watercourses, or around the coast. And that has damp microclimates. So these aren't true aroids of deserts. They're aroids that just so happen to be in deserts, but they're still in pretty standard conditions for aroids. Again, cheating. This I found interesting. Denny says, and I quote, "The Mediterranean Sea is a mere fragment of the much larger Tethys Sea that once extended from the western limits of the Mediterranean right across to India. After the continents collided, buckling the Earth's crust into the great mountain ranges of Europe and Asia, the sea diminished and the climate became drier. This change effectively cut off species that had reached Eurasia and northern Africa from their tropical relatives, and further migrations from tropical regions to the north were prevented by the encroaching deserts of Africa and the Middle East," which does better explain the presence of these aroids in this drier climate when they're still, like, they're not fully thriving in a dry climate. They're finding moist microclimates or suitable microclimates within the greater, drier ecosystem. So, yeah. And then humans came in and we changed everything again. So, the deforestation of areas around the Mediterranean led to a decrease in shelter, decrease in humidity. So, the land is bordering today, or 20 years ago, on aridity, so being really, really dry. Degraded vegetation of tough, often spiny shrubs and a resilient herbaceous layer. So Danny's saying there used to be more aroids than there are now, but humans ruin everything forever. My words, not hers. And a lot of these stink, is the conclusion that you will come to by the end of this chapter. These guys are stinky. There's one called the dead horse arum, and according to E.A. Bowles, it's the sort of thing Beelzebub might pluck to make a bouquet for his mother-in-law. Yeah, so it's apparently, it smells like a dead horse. It's very hairy, which is gross. Like, it's got horse hairs and the spadix is shaggy. Like, no thank you. And it's large, greater than 14 inches. So the spadix is held clear of the leaves at right angles to the stalk so that observers are confronted with a full frontal view that is probably among the most shocking sights in the plant kingdom. Thankfully, it only lives on a few islands of the Mediterranean. It's got tubers that develop beneath rocks. And, okay, so the reasoning behind the stench is because the islands in which it grows on are really popular for seabirds, birds of the sea, to like nest and breed and stuff. So it has to compete for the attention of pollinators or insects with rotten eggs, dead chicks, undigested fish. And so it's got to really stand out if it wants to take advantage of pollinators to get the family line going. It looks like a corpse and it smells like a corpse, and insects go, yummy, want that. Apparently, the best place for insects to deposit eggs is in or around a wound or an orifice that provides humidity, protection, and easy access to decaying flesh for the offspring. As the pollinators hone in on the foul-smelling inflorescence and make their way against the direction of the hairs into the dark hole where the spadix emerges from the spathe chamber, an observer's inescapable conclusion is that the plant has devised a resemblance to the hide of an animal, complete with tail and anus. Plants are really gross. Dragon orums. Sounds way better, doesn't it? Hopefully. Less grotesque. It's Dracunculus. It's got two species. One of the species is endemic to Madeira and the Canary Islands, dry woodland and scrub. It's got a creamy white spathe. And apparently it has a semen-like odour. You just can't win. You really can't win. The second species is called, well, it's D. vulgaris, which doesn't sound much better. It's got a terrifying odour of rotting flesh. So then we get to the genus Aurum or Arum, I don't know how to say it. It has 26 species and wide distribution in parts of Europe, Central Asia, the Middle East and Mediterranean regions, and so hot, dry summers, so it fits into this chapter. So they're tuberous, they like heavy, rich, basic soils. We've got things like A. maculatum, A. italicum. They're more characteristic of deciduous woodland, so chapter 4. They're moisture-loving plants. They find scrub and waste ground, cemeteries, ditches, areas around fountains and wells, near walls and boulders, olive and citrus groves, higher altitudes. Coastal areas generally have higher humidity, so you'll find them, even though technically it's still the Mediterranean region, still characterized by an arid climate, they find their niche. There's more research into the gross smelling aurums than the unscented or nice smelling aurums, probably because people have a morbid fascination with things that make them want to vomit. So we don't know much about the unscented ones, just as like an aside. If you're a researcher and you're interested in researching, maybe look at an unscented aurum species. Or don't, I don't mind, it's up to you. Their fruit is glossy orange-red, so herbs, attracting birds, and it's poisonous to humans, so don't just eat random berries, please. So those were the aurums, and now we have the bioaurums. 23 species, slightly narrower distribution, mainly Middle East, North Africa, Mediterranean, Europe. Drier land specialist. Rock crevices, stony or sandy ground, often on limestone. Small plants, flattened spherical corms, and without exception, they have undivided oval, oblong or strap-shaped leaves. They're fairly hardy, but they need a hot, dry rest in summer to induce flowering, and the leaves develop in late summer or early autumn, usually preceded by flowering and ground level inflorescences, but the actual flowers might be underground, which I think is interesting, like really trying to be protective. And their berries are white or pale green, sometimes marked with purple. Their means of dispersal raises some interesting points. So there's a theory that they don't have widespread dispersal, as the chances of the seed landing somewhere appropriate for the seed to take, for it to germinate, are unlikely. So the parent plant has found a good niche, so the little seedy baby plants can stay in that niche as well, because, you know, if you found a good spot, why not leave it, I suppose. Then we get to Aminium, 8 species, Turkey, Middle East, South Central Asia, stony or sandy ground in savannas and semi-deserts. They're difficult to cultivate and rarely seen in collections. Desert aroids. So a hot, dry rest in summer is rather an understatement for what some aroids are able to endure. This is the part where I'm like, well, can you really call yourself, I mean, I understand how the classification works, don't get me wrong, but I'm like, can you really say you're an aroid if you're just this, not lazy, but I don't know. I'm just really judgy of the plants in this chapter. Searing daytime temperatures, glaring light, little moisture or shelter, and in some areas, substrates with high mineral contents. Both Biorum and Aminium have representatives in these outposts. The Biorum is the Biorum oliveri, and we've got the Aminium spiculatum. And we've got the Ambrosina with 1 species, Bassii, 3 inches, smallest aroid in the Mediterranean region. And then we've got the friar's cow, so Arisarum Vulgare. It peeps out from rock crevices and huddles under ledges. It has sagittate leaves and neat brownish-green, white-striped inflorescences from drying sun and wind. And then we get to the voodoo lily, which we have covered before. Well, there's a lot of different genus and species within that, in the Aroid family, that are considered, have the nickname voodoo lily. In this case, we are referring to Sauromatum, which I really hope the person who named this genus was a Tolkien fan. We've got the genus Theriophonum, virtually never seen in collections. Then we've got Typhonium. And we get to Australia. Most Typhoniums live in wooded areas and are therefore described more fully in Chapter 3, and we did cover them in Chapter 3, but several inhabit quite dry places, such as the Typhonium Liliifolium, which occurs in open scrub and savanna woodland in Western Australia and the Northern Territory. And Typhonium Alismifolium has been found in the Central Australian desert. Stylochaeton, very African. It says wholly African genus, so I assume that means it's endemic to Africa. We've got 17 species. Savanna, deciduous woodland, seasonally dormant, like so many of these dry plants. Although few are found in tropical humid forests and are evergreen, I still think this chapter is just a list of aroids that are cheating and calling themselves aroids of arid places, but they're really just aroids and everything around them is arid. You know what I mean? I know what I mean. So they occur in almost all African countries south and east of the Sahara. They're rhizomatous and can survive arid conditions. Go them. Then we got Gonatopus and Zamioculcus. They're African genera that together form the tribe Zamioculcidae, I think. They are considered to be relics from the ancient African flora that survived the extinctions caused by drastic changes of climate in the Tertiary and Quaternary epochs. Seasonally dormant and unisexual flowers. We do have a couple of anthuriums and a couple of philodendrons. We've got the Anthurium Affine, which is nice. We've got the Philodendron Saxicolum, and we have Philodendron Liliifolium. None of these I know. And then we've got Philodendron Biribiriense and Philodendron Cipoense, which again, I've never heard of, and they grow on rocks exposed to the sun. We've got a couple of caladiums in here as well, which is interesting because caladiums here in Australia go dormant in winter when it's cold, and then they're all good in summer when it's hot. So that one I don't fully understand, but they're really pretty. Whether weird and wonderful or commonplace, tuberous aroids are prepared for the worst. Which, again, are they, or are they just good at finding the places that suit them in a surrounding that doesn't suit them? Maybe they're just good at hide and seek? I don't know. But also, So the conditions have pushed the evolutionary capabilities of aroids to their limits. Again, I don't know if I necessarily agree with that because they avoid it by going dormant. Like, I would be more impressed if it was a plant that just lived in full sun and thrived and had, 10% humidity and loved it. But these guys are like, no, I need a humid, I need a moist, I need a shady spot. And 2 meters from me you can grow a cactus. I'm like, no, that's not what I want. So I don't think they're different enough, especially compared to the water aroids, the wetland aroids. They're pretty cool, like especially the ones that grow in currents. I think they're way more impressive. In my opinion, they're way more impressive than these aroids because these aroids aren't very far removed, in my opinion, from normal aroids. Indeed, it is no coincidence that most of the smallest genera of the Arisae are predominantly either aquatics or near xerophytes, the survivors of perhaps much larger groups that succumb to ever more demanding habitats. For those species increasingly exposed to sun and dryness, devices such as prolonged dormancy, narrowed foliage, underground flowering and fruiting, and limited dispersal of seeds have ensured not only survival, but have marked them out as the family's pioneers in the fastest growing habitat on Earth, arid land. And that's our fault, because we cut down them trees and we ruin them habitats. Alright, that's it. Thank you for listening to me spout information and my opinions at you again. We are now halfway through this series, unless I find a way to draw it out longer. If you have any questions about this, let me know and I will endeavour to answer them as best I can. Subscribe, like the video, maybe, or don't, it's okay. I will see you next time. Bye.